Alright, so series. In this video, we're going to look at the sigma notation, some of the first n natural numbers, some of the squares, and some algebra at the end. Okay, so let's get started. We're going to work out sigma 2r minus 1, and r goes from 1 to 5. We want to work out this out in full. Now, if this is completely alien to you, and if you have no idea what I'm doing, have a look at what I'm doing right now. If you still don't get it, go look at your C2 book, go ask your C2 teacher. I'm not going to go into too much detail right now. Okay, so r goes from 1 to 5, so when r equals 1, of course 2 times 1 minus 1, then r equals 2. But before that, we're going to add, because it's a sigma, so it's a sum. Then it's 2 times 2 minus 1, and then 2 times 3 minus 1, plus 2 times 4 minus 1, plus 2 times 5 minus 1. And then this, you just work it out. There's nothing interesting about this. This is 2 minus 1 plus 4 minus 1 plus 6 minus 1 plus 8 minus 1 plus 10 minus 1. And I think this gives you 25. All right, let's look at the second part. So the second part wants the sum of r squared, where r goes from 4 to 10. By the way, I didn't bother writing it up here, but let's do it. So sigma, this is what this is equal to. This whole thing is equal to 25. So now we're working sigma r squared, r equals 4 to 10. All this is really, it's just the sum of your squares from 4 to 10. So it's 4 squared, plus 5 squared, plus 6 squared, plus 7 squared, plus 8 squared, plus 9 squared, plus 10 squared. Again, you can just use your calculator to work what these things are. Or you don't have to. You can do it by hand if you want to, or just in your head. This is, I think, unless I'm mistaken, 371. Okay. Now, something a little bit trickier. So we've got this. So we want to find the following sums using sigma notation. We don't want to work out what this is equal to. We want to write this like this. Okay. So when doing this, you want to find this inside bit. So you want to find your nth term, and then you find, so I've got 2, 5, 8, and so on. Well, clearly my difference is 3, so I want to say 3r. My nth term is going to be 3r, and you can do it two ways. I like going back to the 0th term, and if I go back one term, that will be minus 1. So my nth term is 3r minus 1. You could have done it differently if you want to say, okay, n here or r here is 1, 3 times 1 is 3, so I have to take away 1 to get 2. Anyway, this is just your nth term, GCSE maths, or actually Key Stage 3 maths. So I've got 3r minus 1. Now I'll put sigma there. Now I need to know what my values go from. So what's my lowest value? So r equals, well, how do I get 2? Well, 3 times 1 minus 1 gives me 2, so r equals 1. Okay, how do I get 29? Now, if you're not sure about this, you don't want to, let's just make it equal to 29 and see what my value of r will be. So 3r minus 1 equals 29. Let's solve this. So 3r equals 30. So r is equal to 10. So that's there. Okay, let's do the second part. So try this one on your own. If you're not sure, this one, I'll give you a little bit of a hint. This isn't a arithmetic sequence. This is not one where you can find a common difference. You just need to spot the pattern. What are these values? Okay, well, if I look at each of these, just by looking at them, what they look like to me are cubic numbers. This is 2 cubed, this is 3 cubed, this is 4 cubed, and this is 5 cubed. So it's going to be sigma r cubed. Now, what do I start off with? I don't start off with 1 cubed. I start off with 2 cubed. So it goes from r is equal to 2, and it ends up with 5 cubed. So 5. Now, of course, this is what this is equal to. So I could do this is equal to this. So I could write this equal to this. And same thing with this. This is equal to this. This is what this is. This is just another way of writing this. Okay. Now, the sum of the first n natural numbers. I'm not going to prove this, but you can look at any book, any C2 book, or any, or if you look at your Fp1 book, this proof is given to you. You don't need to memorize this formula. So sum of the first n natural numbers. By natural numbers, we mean numbers that you can count on your fingers, starting from 1 and going up to n, where n can be any number. These are essentially positive integers, excluding 0. And this is a formula. This formula is given to you in your formula book, so you just need to know how to use it. So we want to find sigma r from r equals 1 to 50. So here, when it was sigma r from 1 to n, So half n plus 1, you plug this n into this, and that gives you there. So you plug it in there. So we do the same thing here. So it's a half times, now my n is 50. So half times 50 times 51. And that is equal to, again, just use your calculator for this. And that's equal to 1,275. Okay, so this is a little bit more interesting. Notice I can't just use my formula directly. My formula is from 1 to n. It has to be, this is fixed. This is from, you start off from 1, your starting position. This is 50, so it can't do that. Well, you remember back to lessons what we do. We say, this is exactly the same as if I worked out my first 100 terms, the sum of my first 100 terms, sigma r equals 1 to 100 of r. And from that, well, this is way too big, isn't it? What do I need? I have to take away all the extra terms I have. So I take away sigma r equals 1 to 49. Now it's 49 because I want my 50th. My 50th is included. So I don't take away my 50th term. I take away my 1 to 49th term. Now I use my formula for each of these separately, and I have my answer. So this is just simply, so for this my n is 100, for this my n is 49. So this one is a half times 100 times 101. So half n plus 1 minus a half times 49 times 50. And just plug it into your calculator and you'll get an answer of 3,825. Now there is an alternate way of doing this. If you look at the book, I'm not going to go through it right now. It's a slightly smarter way of doing it. It may not take you more time. What you do instead is you make this, use a different variable, so say k or s, and make this go from 1. So instead of working out 2 sums, you work out 1 sum. Look at your book. Look in the textbook if you want to have a look at that. Again, you don't need to do that. This will work. Sometimes that other method is a little bit quicker. Sometimes it's slower though. Okay, so 2 other formulas. Again, I think these aren't proven in the book. I would prove these using proof by induction, which is a Fp2 method. Again, it's not so important where these came from right now. You can just say the sum of the first n squares has a formula. The sum of the first n cubes also has a formula. These formulas are given to you, so all you need to be able to do is use these. Another thing, so the next important bit is when given a sum. So if you look at this is sigma a f of r plus b g of r, where f of r and g of r are some functions of r. So in the past, there could have been r squared or 2r plus 1 or whatever. It doesn't really matter. What this says here is you can split this up, and you can do 2 things. First of all, you can split this up into 2 sums. So sigma a f of r plus sigma b g of r. And then this a is a constant that we're multiplying all of this by. We can take that on the outside. And I'm not going to go again. It doesn't take too much working out to see why this is true. I covered it in lesson. I think the book may go through it. You don't need to know where it comes. You just need to be able to understand it and use it. So let's look at example 1 here. So I've got sigma from 1 to 10 of r plus 1, r minus 3. Now I can't split this up yet. So what do I need? I need an addition to split it up. Or I need something factorized I can factorize out. I can't do that here. By the way, notice this a and this b are constant. So you can't just take out r plus 1 because r plus 1 is not a constant. R changes. R goes from 1 to 10. So when you see something like this, you do need to multiply it out. So I've got sigma. That is equal to, so let's just multiply out the brackets here. So it's r squared minus 3r plus r, which is minus 2r, minus 3. And r still goes from 1 to 10. Now I'm going to use this. I'm going to split it up into 3 sums. So this is sigma r squared minus 2 lots of sigma r minus 3 lots of sigma 1. Now, was it covered in the previous slide? It wasn't. Now, this is really important. You should know. This is another thing. This is something not given to you in your formula booklet. So sigma 1 r from 1 to n. What am I doing? I'm adding 1 to itself n times. So this is just n. You need to remember this. This often, I've seen in a recent paper, if you just use this, that gets you at least 1 mark. And if you don't use this, you go wrong and you lose many, many marks. Okay, so now we just need to use our formula. So this is r from 1 to 10, by the way. R equals 1 to 10. Now, if I was just doing this for myself, I wouldn't bother putting these in. I would just put them in at the end. Well, I'd know what I'm doing. But for clarity, I'll just put them in here. Now we just use the formula. Now these formulas are given to you in your formula booklet. You don't need to know them off by heart. So sigma r squared, r goes from 1 to 10, so that's a 6. It does start from 1, which we need to check, so it says 6. Here it's 10. 6 of 10 times 11, which is n plus 1, and 2n plus 1, which is 20 plus 1, which is 21. And this is minus 2 lots of sigma r. Sigma r is what we had before, so it's a half n plus 1. So here again, my n is 10. And I've got minus 3 lots of sigma 1 is just n. So minus 3n. Okay, sorry. Sigma 1 is just n when r goes from 1 to n. In this case, r from 1 to 10, so sigma 1 is from r and 1 to 10 is 10 because I'm adding 1 to itself 10 times. Okay, so we just multiply all of this out. You can just plug it into your calculator, whatever I get, and that gives us a value of 245. You can check that if you want. Again, I'm just following the integral notes along right now, so if you want to see more detailed working out, just go to integral, find the series, find AQA Fp1, and then this is under algebra and series. Okay, so let's look at example 2. Let me just. Okay, example 2 is sigma r squared times r minus 1 from 1 to 20. Again, like before, we just multiply this out and then split it up. Okay, so I'm going to get rid of what we did before. So this is equal to sigma. For now, I'm going to leave out that 1 to 20. It doesn't really matter. We're only going to use that when we actually work things out. So it's r cubed minus r squared. And we split that up into 2 sigma. So sigma r cubed minus sigma r squared. And these are going from 1 to 20. R equals 1 to 20. R equals 1 to 20. And now we just use our formulas. That's it. So this is a quarter. N squared, here n is 20, is a quarter, lots of 20 squared. And if you look at the formula, n plus 1 squared, so 20 plus 1, so it's 21 squared minus a 6. We're using this formula here, n plus 1, 2n plus 1, so 6 times 20 times 21 times 20 times 2, which is 40 plus 1 times 41. Okay, and we plug that into our calculator and we get an answer of 41,230. Okay, and one last thing. Example 5. So this time, if you look at it, we don't have a top number. It's just n. Well, in these kind of questions, you do exactly what you've done before, except now your answer will be in terms of n. Often these exam questions, they say show that something and then it's equal to something else. You can ignore what the final answer is for a while. You just need to do what you normally do, except instead of plugging in a value for n, you just plug in n. So first thing we want to do here is we want to split this up. So this is sigma r squared plus 2 lots of sigma r minus sigma 1. Of course, these are all going from r equals 1 to n, 1 to n, 1 to n. Notice I've stopped writing r here. It's usually, in some textbooks, you'll see they don't bother writing r because it's assumed, of course, it's going to be the r. It's not going to be s or anything else. Okay, so what are these? I just use the formula. This is really easy now because from 1 to n, I don't even need to plug in a value of n. I just copy this whole thing out for sigma r squared. So it's just a 6. n plus 1 to n plus 1. What's this? Well, sigma r is a half n plus 1, and I've got 2 lots of that. So 2 lots of half, and you can already see that will simplify. But let's leave it there for now. n plus 1. And this is just sigma 1, this is just n, so minus n. Now, usually at this stage, what you need to do, now in this example, they haven't given us an n goal, so we are done. We've done what they've asked us to do. Usually they'll give you some kind of end result, we won't look exactly like this. You're gonna have to do some kind of factorizing and simplifying. So let's see what we can get to if we do any kind. Is there any kind of simplifying or factorizing we can do? Well, first of all, we can. This becomes a 1, doesn't it? And then looking at everything else, what is, when you're doing these, what is in every single term? Is there something that's in every single term? Well, looking at this, well, there's an n there, there's an n there, there's an n there. So that makes me think, oh, let's just factorize that n out. What do I have left? Well, inside here I've got a 6, n plus 1, 2n plus 1. Inside here I've got 2 times a half, lots of n plus 1. Well, 2 times a half is just 1, so let's just write that as plus n plus. So this is just a 1, and I've taken this n out, so that's just an n plus 1. And from here I've taken out, the factorize out the n, so it's just a minus 1. Now, if you look at this inside, I can't factorize out anything. There's no other terms. I could multiply these out and simplifying it. I'm not going to because they haven't asked me to, but sometimes you may have to do that. And then once you've multiplied it out and then simplified it, you may be able to factorize again. But I'm going to stop here. Okay, so now, again, as always, go away, do some questions on your own. Integral has questions on this. You can look at exam questions. You can use past papers.